Okay, problem number 13 from the homework shows a bunch of current carrying wires that are carrying current either out or in, shown by the dots and X's, and a bunch of imaginary Amperian loops. And it's asking you to use Ampere's law to figure out how much current is inside each of these loops. Because remember, Ampere's law is the integral B dot ds around a closed loop equals mu naught, that constant, times the amount of current that's passing through, or it's inside that loop. So if you look, for instance, for loop C1, you could see there's just one current inside, the current I1, which in my case is 5 amps coming out. So you would just put 5 amps here. But note, it's only 5 amps there because the current has a circular field that goes around it. Using our right-hand rule, the field circles counterclockwise. Notice my fingers, that counterclockwise field, arc in the same direction as this arrow here that they're going around the loop, doing the line integral with. So when B and that arrow point the same way, then you put a positive answer down here. So in this case, you just put +5. If you look at loop 2, I have one wire in and one wire out inside loop 2. So you can see I3 is in, that's 4 amps in, and you have 5 amps coming out. So that's a net of 1 current out, or 1 amp out. So if you point your thumb out in the direction of the net current, curl your fingers in that direction around that current, you'll see your fingers curled the same way as C2. So this would just be 1 amp for me. Okay, that's pretty easy. But what if you have a more complex picture? Look at number 3 here. Loop number 3 has 3 wires poking in and out. As we saw with these two, there's a net of 1 amp out, but I2, in my case, is 3 amps coming in. So I got 1 out, 3 in. That's a net of 2 amps in. So of all the 3 wires in, I have a net of 2 amps in. So pointing your thumb in the direction of current, my magnetic field circles this way, clockwise. That's the opposite direction of that C3 arrow. Therefore, the answer should be negative. So negative 2 amps would be the answer that you would enter. So if the net magnetic field points the opposite way of the arrows, put the net current as negative in for these answers.